So, welcome to my presentation. First, before we start, I would like to ask, how many software engineers do we have here in this room? Raise your hand. Yeah, almost the entire room. Now, another question. How many software architects do we have here in this room? Wrong. It's because everyone is a software architect. Also, you as a software engineer. It doesn't matter if you are intern, if you are junior developer, mid, senior, doesn't matter. Everyone is software architect. If you are not, then it's time to switch your job, or at least team. And I would like to answer the question from the presentation from today. What every software architect should know about infrastructure? Everything. Thank you. There is a feedback. And that's it. Now, let me tell you my story before. And then you can leave. So, when I started as software engineer, it was 2011. The only thing that I was thinking about was to survive. And I didn't care where my application is hosted. I just cared to deliver the feature or part of this feature and not to be fired. And you know, you might smile, but this was the time of the ivory tower architects. Do you know this ivory tower architects? Like, kneel and pray for forgiveness. So this was the time. And only then I started slowly to think about infrastructure. So first what I learned was Azure. And it was back then in 2014. So look, almost 3 years, and I didn't care about infrastructure. There were some MS builds, but this was kind of a crap. Then I learned Kubernetes, but this was the time when Kubernetes got released, so it was really like the fresh topic. It was like, yeah, I want to do that because I want to have my CV-driven development. And then I was thinking that I knew everything, really. And then came AWS, GCP, RabbitMQ, Kafka, serverless, load balancers, API gateways, Prometheus, Loki, Grafana, Key Vaults. Yeah. If I would have to know everything as a software architect, and I would need to know it deeply, it won't be possible, really. So, yeah, I made a lot of mistakes. I'm not proud of it, but who cares? Short blah blah before we go next. So, who am I? I am Maciej. Everyone calls me MJ. Everyone who does not live in Poland, because, you know, it's quite hard to pronounce my surname. And I'm an open source contributor. I also sponsor some open source projects because, yeah, I like this open source work. I love domain-driven design, but we won't talk about it today. And I am living in Switzerland. You might have heard about my book. I released it in August. If you haven't, then there are some coupon codes at the registration desk. You can grab it. And yeah, feel free to share your feedback if you are interested in it. I am describing there the software architecture from the holistic perspective. So infrastructure, security, understanding business domains, microservices, modular monoliths, and many more. And it's time for showtime. First thing that I would like to talk about today is denial of service and distributed denial of service attacks. Did you have in your experience such an attack for your application? Or maybe 1, 2, 3, 4, yeah, 5, 6, 7. Maybe you don't even know that there was such an attack. Who cares about the bill, yeah? Business. So, one example here, why it is so important. There was a guy who wrote on Reddit this year his story about, Netlify. So he had static site and he hosted it on Netlify. And Netlify has some kind of pricing, starter pricing, where they don't charge you up to 100 gigabytes of bandwidth. But then with small letters, it's written $55 per next 100 gigabytes. And this guy didn't know that. He thought it's free. And then he was attacked. Of course, one might say, hey, Netlify didn't do a good job because they should just cut it when there was this DOS attack. But of course, he could as well read about it. And the bill was $104K for static site. Hey, it's like buying a really good car instead of having such a bloody static site. And luckily, I think he paid like 5,000 because they said, okay, yeah, you made a lot of rumor on Reddit, so let's decrease it to 5,000. But that's why it's very important to think about the good defending against DOS and the DOS attacks. Do you know OSI model? Raise your hand. Yeah, quite some people. You attended to university and this was the last time that you saw it, yeah? Yeah. So in OSI model, we have several layers. First layer is HTTP, FTP, gRPC, so we call it application layer. Then we have layer 6, presentation, where inter-encoding serialization is done. Layer 5, connection establishment, TLS, and so on. Layer 4, UDP, TCP. Layer 3, network, IP, packets, and so on. Then we have layer 2, where we are talking already about switches, bridges, operating on MAC addresses, talking about frames. And layer 1, which is physical. Here we talk about fiber, radio signals, electric signals, and so on. And where this DOS and DDoS attacks come to is usually layer 7, 4, and layer 3. So how you defend against it is that you can either use, first of all, minimize possible points of attack. So if you really don't need to make your endpoint public, don't make it public. Make sure it's not exposed outside of your application. Then you can use some built-in mechanisms as well, like AWS Shield, Azure Front Door. They all support layer 7, layer 4, and layer 3 protection. It's sometimes easier, it's sometimes harder to configure it, or use third-party software like Cloudflare. It will be a little bit cheaper. The next topic that I would like to talk today about are exploding costs. Did you have a surprise with costs of your application? Anytime? Yeah, some people here did it. Do you know Kara app? Has anyone heard about it? Kara app is an app for artists, and artists are putting here some images which are not AI generated. So they share their own work, and this application got a lot of traction. It went viral. And the problem there was that the guys here, they used serverless solution on Vercel. They used Vercel functions, and it auto-scales really well. And it auto-scaled really well. It handled the traffic, but it was again around 100K, and these were, if as far as I remember, students, so they were not able to pay that bill. Luckily, of course, it got a lot of interest, so investors and so on, so they were probably able to pay it off. But still, this is something to always remember. If we put auto-scaling, then you need to be aware that it might go viral, and it might generate huge costs. So sometimes it's better to just say, hey, scale to 2-3 instances. If there is more traffic, who cares? If you have no money, of course. Then the storage. 10 million users. A lot or not? A lot. Each user uploads 100 images. Each image can be maximum 5 megabytes. So when we calculate now, it's 5 petabytes. A lot or not? A lot, already a lot of data. And now we have pricing from one of cloud providers. It's of course hot tire. It's not cool, it's not archive tire, it's a hot tire. Is it a lot or not for a gigabyte? This is per month, of course. If we take into consideration 5 petabytes, it's 115K per month. Per month. And that's why it's important to know that your data might need these hot tires. Maybe some of your data will need cool tires, maybe some other data archive tires. So imagine that you are having a social media application. Your profile photo, it might be on a hot tire, maybe it's a static file living somewhere on a static hosting, but you might have also some files which are rarely accessed, like images, you know, the scrolling when you find your colleague from high school, yeah? You are scrolling, and then randomly like the photo, yeah? So these are the kind of photos which can be stored in this cool or archive tire, so they are rarely accessed. Yeah, not to be sorry for the monetary losses. Next is logs. And with logs, I had some situation where the expectation was 10K per month. For logs, acceptable cost. For a large application, it's completely fine. The reality was 500K a month. Way more. Why? Because they were logging everything. Like, why do you need these logs? Do you use it? Yeah, you know, we might use it. If there is some problem, we will be able to find it quickly. But really, do you use it? Do you need it? Well, yeah, we might not need it. Okay, plus 40K, and so on and so on. So they were able to decrease it to, I think it was around 40K per month from 500K after thinking about these logs. Another thing is some kind of trap. Trap with free credit. Each cloud provider, and not only, because there are also hostings, they provide you something like, hey, for first 2 years of your startup, we give you 300K per year to use with our cloud. What do startups do? They are locked within the vendor because, hey, we have here service, this other service, and another one, so we can just build our solution from the services. And then it's free. It's free for first 2 years. The third year comes, and unfortunately, it generates huge costs like 50K, 100K, and for startup, which is in an early phase, maybe pre-seed or already seed A, it's a lot of money. And that's why you need to be aware that using free credits is free for some time. And if you build some solutions, after validating it with the market, let's say you build startup, after 3-4 weeks, after validating it, you are switching to another solution because you can see, okay, it might be problematic for us in a year or in a 2 years period. That's why it's important to always look at it. And my favorite part, this is like, I love deployments. Who loves deployments as well? Raise your hand. Not a lot, probably you are software developers, DevOps. Yeah, software developers usually do not like it. Do you remember this one? It's fake. I think it's fake. At least from what I found, it's fake. But of course, CrowdStrike did some mistake. And all the systems in the entire world, or maybe not all, but a lot of systems in the entire world, they were affected. And there was a lot of voices like, hey, they could do rollback, amateurs. But the problem is, how would you do the rollback if you can't boot your system? You can't. So possible solution is to select correct deployment strategy for your case, for your context, for your environment. And one of such solutions for deployments is the easiest one, the big bang, the basic. So we have users. Users are accessing our application, then development team provides new version, and while they provide this new version, they find some spot during the day, for example, non-working hours if we are in a single zone. If we are in multiple zones, they need to find the zone which will be affected least. So then they update prod to the new application, and then all the users can access it. So there is always a window for update. There might be a lot of things that go wrong, so unplanned. Maybe some bug, you spot, okay, it's not working, so we need to replace it. A lot of stress, you sweat. Your business says, hey, what are you doing? Man, it was supposed to be 1 hour and now it's 5 or 8 or 24. Yeah, this is this basic one. So to solve the problem of having offline environment, you can use blue-green deployment strategy. And this looks that way, that we have application 1.0. Let's call it here a blue one. Development team deploys in parallel application 1.1. There are a lot of validation checks, tests, and so on. They can be automated, that they can be done manually, whatever. And after everything is fine, all users are redirected to application 1.1 from application 1.0, no downtime. If something goes wrong, they put the traffic to application 1.0. It's great, but on the other hand, the problem is that they will see everything here in this application 1.1, and everyone will see what is inside application 1.1. So there is something like feature toggle that you can use, and with feature toggles you can say, hey, these users do not need to access, or they can't access feature that we introduced, and only early adopters will do that. It can be based on user groups, user roles, whatever you have in your application. But still, it's quite heavy, because 100% users are immediately redirected to 1.1. And here, the environment is replaced with blue or green environment. So when we had blue environment with 1.0, then it is replaced with 1.1. Then 1.1 is replaced by 1.2, which is blue. Then blue is replaced with 1.3, which is green. So blue and green, they sometimes are prod, they sometimes are some kind of your rollback stage, whatever you call it. And to solve the issue with all users who are accessing the environment, there are two deployment strategies. One is my favorite one, but also the hardest to accomplish, because it requires a lot of expertise and a lot of, let's say, developers' knowledge, and also being accountable for what we are doing. And this is called canary release. And canary release works in a way that we have application 1.0, users are accessing this 1.0 application, dev team is deploying 1.1, and then by percentage, we are redirecting users to the new application. And after, for example, 10%, it can be 5%, it can be 1, 3, 7, whatever you say. Then they access the application 1.1. And you observe, it can be again automated. If there are a lot of 400s, 500s errors, then it means something is wrong. If you observe that normally users are accessing shopping cart like 1,000 times per second, and within your new version and 10% of users, there is like 1 or 2 accesses, this means that you probably have bug in your shopping cart, so you should think about just dropping the version and redirecting again this 10% of users to 1.0. If everything is fine, then you increase this number of users to the new version of the application. At some point, it would be great if 100% users will access it. And here you can as well use feature branches. If you wish, you can use feature branches. The good thing about the strategy is that usually all the mistakes are caught before it goes to production to 100% users. There are sometimes cases, however, where you won't be able to see that there are problems, like with 80% of users. You then redirect 100 and you see that you have some problems. Maybe these are performance problems, or your application is not answering. Maybe there is some out of memory exception or so that you were not able to spot when there were 80% of users. Another deployment strategy that is quite common, but it requires at least 2 instances of your environment, is a rolling deployment. Rolling deployment works that way that when we have, like here, 3 instances of application 1.0, where we have a split of 33% of users, don't ask me where is the 1% here on this image, then when dev team deploys the application version 1.1 to instance 1, you check with this 33% of users if everything is fine. If everything is fine, then it rolls another deployment to instance 2. When everything is fine with 66%, then it rolls this new version to the instance 3. And this is the way how you can smoothly update your environment. So if you ask me, what could have CrowdStrike done? For sure not rollbacks. They should just think about better deployment strategy, and probably they have already thought about it, at least I hope. But when running multiple versions in parallel, there is a new problem, or at least one, usually several problems. Imagine that we have a table, and this table of employees, it stores information like first name, last name, email, hire date, many other columns, and also the address. And address is a required field. There is a need to move address from this employees table to another table. And now we need to think and plan the entire change. You can't do it just like, hey, let's drop the table, and now we have 2 in parallel running versions, version 1.0 and 1.1, because 1.0 needs the old schema and 1.1 needs another schema of this new table. So you need to split it into several steps. How can it be split? This is one of the ideas how you can do that. So we have application 1.0, it reads and writes to the address column. Like here, you see this Canada stuff. Now we introduce version 1.1. What we do is we still read and write in application 1.0. Nothing changes here, but application 1.1 keeps reading and writing to application 1.0, so the old column, and also it adds a new optional column where it reads and writes, like the address new table. As you can see, there is data that is now replicated between 2 tables. That's fine at the moment. We have 2 apps which can work with the same database schema. Now we cut out our application 1.0. So what we do with application 1.2, we read and write to the new table, and we stop writing to old table. We keep reading, so we still want to keep reading. Of course, you need to adjust also code. It's not just a database. Then in application 1.3, we migrate the existing entries from the old table, because there might be data which came way, way before, like Canada, or maybe there is Poland, and so on and so on. And we stop reading from the old table. We don't drop it, because you should always plan it in a way that there is one major change per version. It's safer. You can, of course, deal with that within one version, but it's better to just plan it for several versions. And version 1.4, what it does, it just drops the column. So it's a lot of work, and if we plan wisely, we won't have problems, or we minimize the risk of having problems. Maybe this is the better saying. Just plan it always like step-by-step migration plan. Another thing is continuous deployment. Who hasn't heard about continuous deployment? Raise your hand. Okay, there are some guys. In general, continuous deployment. We have guys who are working together. I am now talking about continuous deployment by the book, really, like when you hear this LinkedIn guys or X guys or so, it's by the book. So you have 2 guys or more working on a feature, and they do mop or mop when there are more than 2, pair programming when there are exactly 2. They push changes to the trunk. Trunk can be, for example, your main. There are no branches at all, so we are just working like committing to the main. Now, this introduced changes, they push the trigger the pipeline. In pipeline, we have all the build, we have unit tests, integration tests, static code analysis, and other validation checks that you want to do. Then the pipeline will deploy the production candidate. There will be some smoke tests probably run on your production candidate, and when everything is fine, it is promoted to production. There is also another concept which is called continuous delivery. And the only difference that it has is like there is a manual step like triggering of this deployment. So we can still continuously integrate our code into the trunk, but at some point there will be someone or something that manually triggers the deployment. So it is not done automatically. It's called here release manager, but it can be a scheduled task or so. And if you ask me, or if you have asked me like 6-7 years ago, I would always say, go with continuous deployment. There is nothing better than that, and we can always go there. The problem is that we can't. We can't. Imagine the situation. You are working for a company that also produces some devices. This device can be a cable cutter that cuts cables, or maybe it can be some measurement device that has a laser. With continuous deployment, when we are deploying new version of the software, it's great because it's always integrated and we see the result in our environment. But if you do the application like a web app and button is outside of a modal window, nothing bad happens, yeah? Of course, customers will be pissed off and they will say, hey, what did you do? Just fix it. And we will fix it, easy. But when you have such devices, and you release new firmware, there might be a situation when someone's hand is cut or someone's got blind because of this laser, and it won't be easy to roll back. That's why in such environments which are highly regulated, where you have external audits, where the external auditors will spend 2 weeks on testing some firmware before it is uploaded to the device, then such situation like continuous deployment or delivery, it doesn't make a lot of sense. But if you are building a critical system, there you will also have a lot of regulations, a lot of audit checks, security, and so on. So these are applications where you probably won't do that. But in other applications like web apps that are like e-shops or after sales desks or maybe appointment scheduling, this is something that can be easily handled, and this is something that I would always say, try to do that. You don't need to deploy your application multiple times per day with continuous deployments, but if you can deploy it like 2-3 times per week, it would be great. Just don't fall into this trap of doing it 6 times per year, because then quickly a legacy system will be created. So here there is some kind of statistics from 2024 already. You can see that unfortunately this red bar grew in Q1 2024. This means that a lot of companies still deploy less than once per month. This is what I am talking about. This is let's say 6 times per year. And in a lot of cases, it's just bad. From perspective of multiple deploys per day, this is this holy grail that you would like to, or you even don't know that you would like to have. This is just 10%. So it means that still 90% of the companies do not do continuous deployments. So don't feel bad with that. But if you are somewhere here, it would be great. Of course, if you can. Another thing from the software architect perspective is cloud. There was a lot of cloud in the previous session from Piotr. Here I would like to just focus on 2 things, being cloud specific and being cloud agnostic. From being cloud specific means that I take AWS, I take Azure or whatever else, and then I am using its own services. I am using platform as a service offering that they have. And this is easy to set up, very easy and fast. You have automatic updates and maintenance that you don't need to care of. So if you don't have your DevOps or you are not DevOps, this means that it might be a solution for you. Then it's compliant and secure, or at least it should be. Maybe that's a better naming here. It has integration with a lot of services from the cloud. And the scaling is usually simple or very simple. But there are problematic scenarios. one scenario is that your company runs everything on AWS. But there are 2 teams in a company out of 20 teams that were accepted, approved to run their services on Azure. So guys from this team, they just used everything from Azure, all the services that they could think of. But then after 1 year, someone comes and says, you know what, we need to integrate it all to AWS, that we have entire company in AWS. And this Azure team or Azure teams, they will need to rewrite the system that they built from scratch, at least from the infrastructural perspective, because there is no Azure message bus in AWS, yes? So this is something that you will need to rewrite. Of course, there are some solutions, maybe some library that supports as abstraction, that supports several clouds. So this is something that you can use. You don't need particularly to drop everything, but still it will require a lot of work. Another problematic scenario, this is Switzerland. Imagine that, and the information that I am showing now is fake. We have cloud provider A that has region north and region south, and cloud provider B that has region north and region south. And yeah, we build it with one solution, one cloud provider, this green one, Cloud B. But there is a flood here, and there is a flood here, because there were a lot of rivers, there are lakes, and so on. It was redundant because, yeah, we had 2 regions. Great. The problem is that both are not working. So that is a chance that you might need also another cloud provider. If your application is mission critical, it might make sense to have it at least prepared for 2 cloud providers, where a second cloud provider is acting as a backup. Of course, there might be a cloud provider that says that they have 2 different availability zones somewhere, and then it appears that it's in one building. It happens sometimes. Cloud-specific problem scenario number 3. You deal with the solution for Europe. And it's great. Your customers are happy. You say, yeah, we are using this cloud provider. Great. It can be Azure, it can be AWS, GCP, whatever. And in each country, like you go from Spain to France, from France to Italy, from Italy to Switzerland, Austria, Germany, and so on. Everyone accepts it. It's fine to run it on this cloud. But then you start selling also to this country. And this country often says no. No provider A, no provider B. It must be our provider. So the one that is inside this country. And this is something that you will need now to also rework, because if you tightly coupled yourself to one of the cloud providers, you won't be able to easily migrate to another cloud provider, which is from China. That's why sometimes it also makes sense to go cloud agnostic. But it has, as always, it depends. It has its pros and cons. One thing is that you don't have vendor locking. This is great. Of course, vendor locking. I am using third party, so I am locked with one vendor, but another component is from another vendor and another from another, and so on and so on. Lower cost of migration in case of such scenarios, like we have served Europe, now we need to serve China, or we have problems with this flooding areas and we want to have it into places. It might be also fire instead of flood, whatever. The consequence is that it will require higher upfront costs because it costs more. It's more expensive because we need to spend more time on setting it up, and we need, of course, for that also full responsibility. So it doesn't work like before, that we don't need to care about updates and so on. Here we will need to care about these updates because no one will care about it if we don't do that. And it, of course, requires more expertise. If you think about this cloud agnostic, cloud specific, it's like in Azure you will have Azure Kubernetes service. So of course, if you want to go cloud agnostic, it's Kubernetes. You will have Cosmos DB. If you want to be cloud agnostic, it can be Mongo. You have AWS SQS, then as cloud agnostic, it can be RabbitMQ. You have Azure monitoring. You can use, of course, also Prometheus for metrics. You can use Jaeger for traces. You can use Loki for logs and so on and so on. But as mentioned before, more responsibility because of updates and patching. And when dealing with distributed systems, we face really big problem of sharing information between multiple nodes. There are usually two main problems. One problem is how do we keep the data consistent? And the second one is how do we make sure that our data is available? And years ago, the guy called Eric Brewer introduced this CAP theorem. And there are following characteristics described by him. Consistency. And with consistency, we must ensure that all nodes see the same data at the same time. So if you have several nodes, they should always have the same data at the same time. This means that write operation is always assumed as complete only when it is completed on all nodes. Then we have availability. Availability means that each working node that receives a request must result in a response. There is no chance that it does not result in response. In other words, system remains available at all times, but it might eventually lead to inconsistent data between multiple nodes. This is something that you might know as eventual consistency. Then there is a third characteristic which is called partition tolerance. So the network can be divided into two subnets that can't communicate with each other. This means that our system should be partition tolerant. If such situation happens, it must still work. And that's leading to the theory of selecting any of these two from three characteristics. That you can use CA, consistent and available, you can use consistent and partition tolerant, and available and partition tolerant. The problem is that in practice, to consider the CA model, so always consistent and always available, you must ensure that there are no network partitions. In real world, impossible thing. So that's why we are selecting from consistent and partition tolerance and available and partition tolerant. And what is worth here to say is that you don't need to select one model for your entire application. Part of your application can be with CP model, part of your application can be with AP model. Let me explain it with some example. Imagine that you have comments section or review in your application. If it is not consistent, so one user won't see the latest review from another user, nothing happens. If they won't see the comments, also nothing happens. But if you have, so we can select this AP model. If you have two ATMs that need to synchronize the information about cash flow between each other, because first I am standing in front of one ATM and my colleague is in front of another ATM and I am taking $100 and he's taking $100, they need to know that the amount which I have still on my account is, for example, 1,000 and not 1,100, because only one ATM got this information. So this is the case where you would use this consistent and partition tolerance when it's critical to your business. The problem with the CAP theorem is that if I, as a user, I send a request to the node and node responds to me after a week, can I say that this system is available or not? I should be, because it responded. But yeah, I already went with my kid to the kindergarten, I ate 5 lunches, 5 breakfasts, 5 dinners, and so on and so on. So probably I just killed my application because I want to wait 1 week to just get a response. Another problem with that is what to do and how to call the system if I am able to read from it, but I can't write to it. Is this system available? Or only part of the system is available? And this is something that comes with alternatives to CAP, because CAP was introduced in 90s, if I remember correctly. And it did not take into consideration latency, which is very important. So PASELC, it says that if there is a partition, the system has to somehow trade off availability and consistency. When there is no partition, we need to know how the system trades off latency and consistency. Another is the one from the guy who wrote this book. This is a very nice book. If you don't know it, really buy it. It's great. It's great. And delay sensitivity takes into consideration availability, delay sensitivity. So here we are talking about latency, network faults as well. It's tolerant for faults, and it's taking care also about consistency. So PASELC and delay sensitivity fit better to the current world. There are also some useful tools that I would like to talk with you about. And it's especially when, you are building application, or you received some application from software house and you feel like something is wrong there, or you just want to make sure that it works as expected without some manual checking. First, we start with something that is completely free. It's called Checkoff, and you can connect it to your pipeline to check your infrastructure. It's really great. You can connect it as a Docker image, so like it's always taking into consideration the latest image of Checkoff, and it shows you that, hey, when you set up, for example, Azure Container Apps, you forgot about this and that, and it's against the policies that we have here. And of course, sometimes their policies are really strict, and probably you won't be able to meet these policies that are here, but this is good because you can skip it while thinking about it. So it's not like it's magically done under the hood. No, if you see, okay, I can't fit this concrete policy, this concrete rule, I am skipping it, and I am conscious about that. We did this as a team, this decision, and this is our decision. We did it, and we skipped it. So it's possible to skip it. It's really great. Another one, this is probably something that you already know. Have you ever worked with SonarQube and SonarQube? Yeah, a lot of you. This is a great, great tool that will help you to keep your code. I don't want to say it will help to keep your code clean, but it will help to keep it maintainable. This is something that I like about Sonar. Another one is Sneak. And this is something that I really like, especially when you are falling into some legacy application, or as I mentioned before, some software house delivers you some application, and then you want to audit it. The easiest way to do the first audit is to just run Sneak checks, and Sneak can do a lot of things. It will tell you that, hey, there are problems with your classes, there are problems in your YAMLs, there is problem within your infrastructure scripts and so on. So this is cool to check. It costs money, but if you are playing around with that as a hobby, then I would say look at it because it's worth it, absolutely. Another thing is K6. Has anyone used K6? Good. JMeter? Okay, the same guys, hey. How do you select it? So K6 helps you with making sure that your application will be able to handle, for example, high peaks, like for Black Friday or so. So it's more like covering the area of load tests, area of stress tests. And this is something that you can use. It's open source, and you will like it for sure as well. And from the summary perspective, because you might feel overwhelmed after today's presentation. In the beginning, I told you software architects should know everything. It's true, because software architects are kind of generalists. But still, you don't need to know everything in detail. Think about things like load balancers, API gateways, maybe Kubernetes, cache, Kafka, things that repeat within almost every commercial application. And while focusing on it, you will already have some kind of holistic view on software architecture. Add to this also security stuff, selection of the testing strategy, and you will have this knowledge as software architect that is in general good enough. And that's it for today's presentation. I would like to ask you if you have some questions. I hope you have. Guys, maybe you. Really no question? Then I invite you to just come to me and we can talk a bit. Unfortunately, I need to leave in half an hour or so, so if you have some questions, just come. Thank you very much for attending, and yeah, have a great rest of conference.